The Machine Intelligent Slope Stability Laboratory at the Geosciences Department of the University of Padua has been established a couple of years ago in 2021, between 2021 and 2022, with the aim of applying artificial intelligence technologies to all the different applications possible in landslide studies, landslide hazard, or in general for hydrogeological disasters related research. And in specifically, the laboratory has been working a lot on developing techniques in machine learning and deep learning for different steps in the management of geological risks connected to mass displacement and landslides, starting from the detection of this kind of disasters from satellites or other new technological platforms, going down to the detection and measurements of local and general or large-scale properties of these mass displacements, trying to study their causes and anticipating the effects to increase the level of safety of populations and of elements at risk. And for doing this, we started working with normal computers and machines, and then we quickly discovered that we needed more. Now, we needed more powerful techniques and more powerful machines. So the Department of Geosciences, together with other departments of the university and using the funds from also the excellence projects, started to build a new cluster with a very high computational capabilities, which is based on this new computational core you see here, which is the NVIDIA H100 machine, which is built on 8 different of these tensor core GPUs in a small cluster machine called a DGX H100, and the university has been buying several of these machines and putting them together in a cluster which is more complex than the one. This is what we are achieving right now, the steps at which we are at the moment in building this. The objective is to reach an ensemble machine like this one, which will be very powerful. What we want to do with this kind of machines, what we are doing actually at this moment as a machine intelligence slope stability laboratory are several different applications of artificial intelligence, starting from the analysis of interferometric radar satellites to detect and measure ground displacements due to any geological or even non-geological causes, using deep learning method to extract from optical images aspects and maps dealing with disasters, effects of disasters, traces of hints or map of the effects of geomorphological processes active on the surface that may represent hazards, also extracting the same information from radar images, which have the advantages of being available also during the night and under cloud covers, because microwaves can penetrate clouds, as in this example here. And then, after extracting this information with deep learning, using other machine learning methods to extract precise and detailed information on those processes, like the volumes, the typology of process, the mechanics of the process behind, and being able to study this information, which usually are not available if not extracted by using these artificial intelligence methods. Same as the study of connecting these effects with their causes, especially when they are linked to climate change effects. And so for us, for example, to understand and study the rainfall and the rainfall amount connections with the disaster is very important, and using this method it's much more effective. And also go ahead with new applications like the use of federated learning for slope stability and other application of artificial intelligence, where federated learning needs a huge increase of computational capabilities but decreases the need of data privacy protection, which is an issue now for safety for many applications. And the sharing of data is not needed in this case, and we can train our neural network models without the people needing to share their data or their private data or classified data with us. Also, we work a lot on the time component to see how this process develops in time, and neural networks and deep learning may also help in predicting and forecasting the future of our disasters or impending hazards on the slopes and all the landscapes of at the global scale. What are the developments we have in mind? Mostly the development we have in mind with MISLab is now to bring all our application to a global scale, so to be able to apply all our models at the global scale in near real time. This is a future project, but it's in the near future with the help of this new cluster machines.
Hi, I'm Sansar Rashmina. I am a researcher at Department of Geosciences at Machine Intelligence and Slope Stability Laboratory. I work mostly on landslides, mapping them using optical data. I have been working on these landslides since last 5 years. So I did my PhD in mapping landslides using machine learning, and now I'm applying this at more global scale. So first I talk about what is the importance of these landslide. Why do we map landslides? And so this is an example of landslides, why they are so difficult to map, especially in tropical environments. As you can see, these are some of the example. Landslides can revegetate very fast, and also they can evolve very fast after an event, mostly in the tropical areas. So to deal with this, and also many landslides can be triggered after an event, and it's very difficult to map them all manually by hand. The question was how we can map them all automatically using machine learning and deep learning algorithms. So I tried to do several works in past years using machine learning, different machine learning, deep learning techniques for landslide mapping. This is an example from Nepal and also from India. And then this led to a global paper where we developed a high resolution global landslide detector data set. It is freely available for everyone. It is available, the codes are available, also the data is available. The paper is published in Earth System Science Data Journal. The model is trained on 10 different study areas globally, and we use different landslide triggers, landslides from rainfall, also from earthquake induced. And we developed a training data set which can be used to train or to test new models for landslide detection mostly. The paper can be accessible from it's open access, and it's available online, the paper, codes and data sets. So this is mostly optical data. Maybe Lorenzo will show you, Lorenzo Nava is a PhD student in our group. He will show mostly the next step, how we can use synthetic aperture radar SAR data for landslide detection.
Hi, I'm Lorenzo. I'm a PhD in MISLab as well, and following up what Sansar explained before, what I do in my research is to use radar data from satellites to detect landslides using neural network, but also in presence of clouds, and this is one of the lines of research. Another things that I do in my research is to try to embed the spatiotemporal dynamics of slow-moving landslides into neural networks so that we can try to predict future motion, but also improve the existing alert systems. It is very important to develop methods that are able to detect landslides under cloud cover because there are multiple events in the world. For example, what happened last year in Turkey or what happened this year in Taiwan, in which we had thousands of landslides in very wide areas, but we don't know where these landslides are. And if there are clouds, we cannot use the conventional optical-based approaches, right? And SAR, it's very difficult also to be interpreted by us. So neural network gives us a hand when it comes to the speed, but also the understanding of this data.
Hi, my name is Kushana Bhuya. I'm a PhD as well at MISLab at the University of Padua. Well, trying to sort of, let's say, complement on what Sansar Rajmina and Lorenzo Nava, they talked about, particularly with mapping of landslides. One of the things that we are sort of often missing is looking at really the basic mechanisms of the landslide itself. So some of the work that I have been involved in is to understand, for example, what are the typologies of the landslide. So are they sliding mechanisms, or how much mobility in terms of fluidization you have, what sort of general mechanisms they can allow or that can be allowed in a landscape that might be triggered by, let's say, earthquakes or rainfall. So those are some of the things that we are trying to understand, particularly with these advanced machine learning algorithms. So one of the reasons why we try to understand the mechanisms of these slope failures itself is to sort of understand, for example, in the future, what sort of intensities at which they might occur. Particularly if you're looking at, for example, a very simple instance could be the volumes of the landslide itself. So we want to know what type of landslides could initiate what range of volumes that can eventually occur in the first place. So for that reason, it's very important for us to not just gather data, as you can see in this slide, where we try to understand across the globe, but it's also important to take into measure the computational needs that we would eventually require, which the cluster at the moment provides us the tools with to model these landslides at such large scales.